Now, as a fan of the current atmosphere of technology, I decided to bring my hobby and technology together. Why not create something that can predict the NFL? My goal here, guys, is to create something that can predict the weekly performance of a player every week. I decided the first thing to do when you want to make AI do things for you is to find food. And food for me is data. I really like this data set. You have the weekly player stats, you have the weekly offense, the weekly defense. I found data on the internet that has so much nutrients that could actually make an AI, an artificial intelligence thing, predict NFL players' performance. This data set is actually going to be something that we use, guys. Think about it. We want to predict the weekly performance of a player. So we want to have a data set that have a rich amount of resources that the model can kind of use to make sense of what makes a player good. After we collected the food, right, I wanted to grab the right ingredients to make the possible AI that I would make to help me predict how a player is going to do on a weekly basis really good. Now, in AI and machine learning, there's this thing they call noise. Noise is so bad for AI. Noise for me is like going to school for science and being taught history. You know, it's not very relevant. Maybe it is. I don't know. But my goal was to do this thing called feature engineering, people. I am an engineer because I featured engineered this huge data set, which is actually about 422 columns. The goal of this script is to basically grab all the important files, the important data files that I think are important, and strip them down to a set amount of columns that make sense. My goal here was to get the general stuff, right? The passing yards, fantasy PPR points, and look at the opponent, the defense that the player is going against. The goal is not to make this too complicated. We got our data set from Kaggle and we're just stripping it down now. We're trying to make it a little more usable. Instead of having the 400 columns that we would get if we combine these together, we want to strip them down to the juicy parts, people. I had to sort of take out the things that were noisy and leave out the things that weren't noisy.
No shit, Sherlock!
Now, after you do the denoising of the data set, guys, data is huge. It's food for intelligence. It's what you can use to make rocks, pebbles, sand think. I had to also think about the kind of model that I want to use. Now, as a novice, as a noob, you have to kind of learn as you do. You have to do experiential learning in the AI. As I looked at my data set and thought about a model to use, I started asking questions. What model would be the best in terms of predicting a player's performance? And this is where I looked at time series models. But then I also wanted to look at things that were good at regression, going directly on one thing. Regress on a number, prediction. I looked into regression models. Now, obviously, with these questions, I had to ask people smarter than me. This is where my manager came in. He's like, hey, maybe try a transformer. The data set that you have obviously influenced the model. That's why some of you guys would see that I have a create sequential data set. And this will be used for a more so transformer model. The feature data set is going to be used for a regression model or like a tree-based model. Zor, what is a transformer? Guys, a transformer is actually not a movie. A transformer is Google, ChatGPT, Gemini. Every chatbot that you use on a daily basis is probably, actually is 100% a transformer. Their goal is to understand context in language, make them somehow make sense with each context of the language.
What?
And output things. If you're smarter than me, you know I'm oversimplifying.
Bro, what are you talking about, man?
Because we want to look at the context of a player, their situation, their snap count, the offense that they're playing with, the defense they're playing against. All of these things sort of depend on each other. Same way how every word in a sentence will depend on each other. That's how every stat will depend on each other. This is why my manager actually told me to look into transformers, and I did. So I have all these files in here, people. All these files are to fine-tune my transformer. I think I fine-tuned a transformer like 3 times or so, and I got the best model to be about 70% accurate, and I was in the T5 transformer model. This model is pretty good, about a 70% accuracy, but I don't like that. I want it to be at least 85%. The classification was like wide receiver 1, bench wide receiver, elite wide receiver, star wide receiver. So the classification can also kind of limit or hinder the accuracy, because like, what's the difference between a wide receiver elite or a wide receiver that's like high? So all of those things can impact how the model seems to perform. The thing is, I can't use a bigger version of this T5 model because I'm constrained by the hardware. If one day you want to become a wizard like me, and you want to make AI predict something for you, you have to think of the machine that you have. If you only have a laptop, you probably can't create things very exciting with AI. So I have a PC, and this allowed me to use the base model of this transformer. I don't want to go too deep.
Hell no.
Am I being too smart, man? I don't know. So after the transformer didn't work, we started to look for other means of exploration, other ways to structure the data set to fit newer models. I used this training set to train this XGBoost model. XGBoost is just a really good model that is really good at doing regression tasks, especially on a tabular data set like what I have right now. It actually used this thing called random search. So it's gonna go through multiple hyperparameter tuning by itself to find the best middle ground and settings to train this XGBoost model and get me just like the best model out of it. I had a MAE of about 0.56. I wanted a really good regressor. I wanted a really good model that can predict things really well. And XGBoost is insane at it. It literally is like the Kaggle model, okay? So I took that and it actually gave me a really good accuracy. It gave me an MAE of about 0.55. This means, right, MAE, the mean average error from all the fantasy players that we had in the training data set was about 0.55. So it was usually 0.55 off, and that's really, really good. That's a really good accuracy. And obviously I'm oversimplifying. Now after you do that, you train the model, you have to find a way to use this model, right? And this is where live data comes into play, boys and girls. This process is going to allow me to use more so live data to get actual and actionable feedback from the model. And that is what these files are for. I had to go out there and grab live data that I could possibly refresh on a weekly basis that have the same amount of columns as my training. Columns are features. Features like boy, black, red, like toys, school. That's what a column is. I had to make sure the data that was grabbing live matched my columns. And then from that, I was able to actually use this model. And I set up a server for it and used it. The accuracy is not bad, but the goal here is to make this as accurate as possible. Even the ESPN models that they use on the fantasy app isn't super accurate. I don't have a front end right now, but we're going to use this right now. Let's say, for example, we are trying to actually test our model. Guys, we're going to use this player, Chase Brown. Okay, Chase Brown, he had about 19.2 points in week 9. Let's see what our model says about Chase Brown here. The model is actually predicting that Chase Brown score about 10 points. But if you look at the performances of Chase Brown over the past, you can clearly see that Chase Brown has struggled tremendously, and the model doesn't really know the context. All right, guys, this is Editing Dixon, right? All I'm gonna say is after we look at the output of the model, we just gotta understand that this model is very limited in what it was trained with. I didn't train it with injury status. I didn't train it with how the quarterback own position could impact the running back and how that could impact the receiver and vice versa. So that played a role in why the model is kind of saying Chase Brown won't be doing well. And if you're a fantasy person that follow football, you know why Chase Brown is doing well. They have a new quarterback. And the recommendation from my manager was also to look into how I can make this more specific to a position. I train a model on a quarterback, train a model on a running back, and then somehow consolidate all of these models together into my application, making it the brainiest AI application the world have ever seen. This is my yapology of AI, and hopefully you like it and you learn something. Peace out. Bye bye. Mwah.